Good morning, everyone, and thank you for coming. As some of you might remember, at last year's online Fechner Day meeting, I gave a personal view regarding the future of psychophysics, and I suggested several areas of potential directions and agendas for psychophysics of the future. Now, many of these included research areas that might not typically be considered within the purview of traditional psychophysics, topics such as metaphor and analogy, perception of causality and naive physics, and music cognition. I thought these different areas could all fit within psychophysics because they all consider the relationship between properties of a referent physical object and properties of the mental representation of that object. Now, what I want to do here today is suggest a theoretical framework that can include these different areas under the umbrella of psychophysics. And such an endeavor is consistent with the suggestions of many previous researchers, including Fechner, Stevens, Baird, and Noma, and Kernbeck, Schroeder, and Muller, all of whom saw psychophysics as extending beyond the measurement of sensation and sensory thresholds. I'm going to suggest a new division of psychophysics, which I'll call medial psychophysics, and a typology of 4 different orders of psychophysics. Now, Fechner made a distinction between outer psychophysics and inner psychophysics. Outer psychophysics is the relationship between the properties of referent physical stimuli and the subjective experiences of those stimuli. And this has formed the basis for the majority of research since his time. Inner psychophysics is the relationship between the brain and the neural states and subjective experience. Okay, so we've got 3 domains: the referent physical stimulus, brain states, and subjective experience. Outer psychophysics involves properties of the referent physical objects and subjective experience, whereas inner psychophysics involves brain states and subjective experience. However, one relationship is missing, and that's between properties of the referent physical stimulus and brain states. As brain states can be viewed as medial or intermediate between physical objects and subjective experiences, I propose to call this relationship medial psychophysics. Although this is missing from traditional or classical psychophysics, it is very much a part of contemporary cognitive neuroscience and theories of embodied cognition. Each of inner, medial, and outer psychophysics can exist in one of 4 different orders, and the differences between the orders involves which type of information from the referent object is involved. With higher orders of psychophysics, information becomes increasingly abstracted and more top-down. Now, many of the directions for a future psychophysics that I suggested last year are consistent with 3rd order and 4th order psychophysics, so we'll spend a little more time on those latter orders today. But I'll start with 1st order psychophysics. This is the lowest and most basic order. In 1st order psychophysics, the information involves physical properties of the object that is available to perception at the time of the observer's judgment or response. Examples include Fechner's law and Stevens' law. Indeed, most of the historical and traditional psychophysics is of this type. 1st order psychophysics is related primarily to sensory functioning. As research in the 1970s, 1980s demonstrated, though, psychophysical methods developed for the study of perception could be adapted to the study of memory. This was referred to by Algom, Hubbard, and others as memory psychophysics. In memory psychophysics, the object to be judged is not available to perception at the time of judgment or response. Rather, the judgment or response was based on memory rather than perception. And I suggest this constitutes a 2nd order psychophysics. 2nd order psychophysics would be related to autobiographical or episodic memory. Now, findings in 2nd order psychophysics often parallel those in 1st order psychophysics. Remembered magnitude, like perceived magnitude, is often related to stimulus intensity by a power function. However, the power function was often different from that in 1st order psychophysics. Now, in some cases, the exponent for remembered magnitude seemed to approximate the square of the exponent for perceived magnitude. An example of this would be area, okay, where the exponent for remembered area was 0.64, which approximated the square of the exponent for perceived area of 0.8. An early idea was that retrieval from memory was like a reperception, and so this was called the reperceptual hypothesis. However, this pattern did not hold up in subsequent studies. Other findings in 1st order psychophysics, those such as the symbolic distance effect and semantic congruity effect, were found in memory psychophysics. Now, in 1st order and 2nd order psychophysics, the observer judged properties that are present in the perceived or remembered stimulus, respectively. However, effects of the likely properties of a physical object can influence judgment or response, even when those likely properties were not actually present. And a good example of this involves subjective contours, which I'm sure we're all familiar with. You can see an example in the upper right of the slide. The configuration of contours suggests boundaries where none are actually present, in this case, a white triangle. Another example involves grouping as driven by Gestalt principles, and you can see that in the lower right of the slide. Closure and good continuation involve imputation of objects. Now, these types of cases in which the queried information is neither perceived nor remembered, but is imputed to the stimulus, these would be an example of third order psychophysics. And third order psychophysics would be related primarily to semantic or conceptual memory. Several other examples of potential third order psychophysics can also be given. For example, existence of spatial biases such as representation momentum, in which properties of momentum are imputed to computer animated targets that don't actually exhibit momentum or in fact even possess force or mass. And you can see an example of that in the middle of the slide. Representational gravity and representational friction would be similar types of biases. Another example involves perception of causality, such as in Michaud's launching effect, in which a moving spot of light that wouldn't have mass or force is nonetheless imputed to cause motion of a subsequently contacted target. And you can see an example of that at the bottom of the slide. I want to take a brief detour now and consider a consistency between third order psychophysics and second order isomorphism. Now, Gestalt theory suggested there were similarities between the structures of objects and the structures of brain or neural representations of those objects or stimuli. Now, this idea was often misunderstood and caricatured as suggesting a structural isomorphism in which, for example, an image of a green elephant would have to involve a part of the brain that was green and shaped like an elephant. In his account of mental imagery, though, Shepard reinvented the Gestalt notion in his idea of a second order isomorphism. Now, this was not a structural isomorphism, but rather a functional isomorphism in which functional properties, but not necessarily structural properties, were preserved. So, for example, just as a rotating distal object, moving from orientation A to orientation C, had to pass through an intermediate orientation B, so too with the proximal stimulus, or the retinal image, and the internal or mental representation have to pass through an intermediate orientation B. Now, Shepard focused on kinematics and geometry, but I later extended this to include dynamics. So just as a rotating distal object possessed momentum, so too would the internal representation of a rotating object possess a momentum, in this case, representational momentum. So second order isomorphism, coupled with earlier examples of closure and good continuation, might allow a tighter connection between Gestalt notions and psychophysics. Okay, from first order to third order, we've moved progressively further away from physical information available to an observer at the time of judgment or response, from perceived to remembered to imputed. In fourth order psychophysics, we don't consider physical information per se at all, but rather agentive or intentional information. In other words, rather than involving physical properties of objects, a fourth order psychophysics involves agency and intentionalities of entities and events. So in many cases, the agentive quality or stimulus might be a human or human activity, but fourth order psychophysics isn't limited to humans. Fourth order psychophysics could be studied in any type of entity or other stimulus to which agency is attributed. And as such, it relates to social cognition. An early example of this involved demonstrations of Hyder and Simmel in which social attributions were applied to moving geometric shapes. In one example, a big triangle was seen as threatening a smaller circle, and another triangle intervenes on behalf of the circle. And I urge you to check out demos of this effect online. They're actually quite compelling. There have been other studies following up on these ideas, such as those by Gao and his colleagues' study of the psychophysics of chasing. Attribution of agency can be extended to non-human animals, and indeed potentially to any element in the natural and man-made world. Along these lines, fourth order psychophysics is consistent with Dennett's discussion of the intentional stance, in which in the absence of design or physical knowledge, we attribute the actions of some stimulus to mental states of that stimulus. It's also consistent with my work on extensions of intentionality to elements of the natural world in shamanism. And indeed, a few other researchers, primarily in social psychology, are beginning to favor the development of such a social psychophysics. Now, there is a caveat regarding fourth order psychophysics, and to a lesser extent, third order psychophysics. And That is that the usefulness of such an approach is related to the success or lack of success of the reductionist agenda. Now, as many of you know, the reductionist agenda in science involves explaining the findings and laws of one science in terms of the finding and laws of a more basic science. So explaining psychology in terms of biology, biology in terms of chemistry, chemistry in terms of physics, and so forth. But the viability of reductionism is not entirely clear. To the extent that bridge laws directly connecting one science to another cannot be found or cannot account for emergent properties or other findings, then reductionism wouldn't be a viable strategy. In such cases, a fourth order psychophysics might offer more useful level of description, generalization, and explanation of the findings in psychology, economics, history, and other less basic science. However, to the extent that reductionism across the sciences is viable, that it isn't clear how useful a fourth order psychophysics might actually be. Okay, well, let me give you a summary now of the differences between the different orders. Now, this table is also in the proceedings article, so you don't have to scramble to copy it. We can see differences in the type of information, the distal properties, labels, related domains, examples, potential reducibility, and type of stimulus. The type of information in the different orders can involve perceived, remembered, imputed physical properties, or agentive properties. Now, these would involve perceptual psychophysics, memory psychophysics, many studies of cognition involving top-down processing, and social psychophysics. They cover a range of domains from sensory function to episodic memory, semantic memory, and social cognition. Examples include Weber's law and Stevens' laws, the reperceptual hypothesis, subjective contours and representation momentum, and social attribution. The possibility of reductionism ranges from very likely to perhaps unlikely, okay, across the different orders. My suspicion is that lower orders will also involve more prothetic types of stimuli, but higher orders might involve more metathetic types of stimuli. Okay. We can also see some similarities. All of the orders involve inner, medial, and outer psychophysics. All of the orders seem consistent with the possibility of an action-specific perception in which perception is potentially influenced by subsequent action. Okay. I've suggested a lot of ideas, so let me now just briefly summarize. First, a medial psychophysics involving the relations between brain states and characteristics of referent physical stimuli was proposed. This completed the consideration of the possible sort of relationships between properties of stimuli, brain states, and subjective experiences. Second, a typology involving 4 distinct orders of psychophysics involving perceived, remembered, imputed, and agentive properties of stimuli was suggested. And this explicitly extends the range of psychophysics beyond the traditional studies of threshold or scaling. And it could bring phenomena previously seen as unrelated to each other or to psychophysics within a common theoretical framework. Examining similarities and differences in the methods, theories, and topics across the different orders could provide a theoretical underpinning and constitute a research agenda for a psychophysics of the future. Across all of the orders, though, the basic goal of psychophysics remains unchanged, and that's to reach an understanding of the relationship between the properties of a stimulus in the world and the mental representation of that stimulus. Okay, thank you.